This is the first video on inequalities in triangles, and we do in this video is we cover a couple of different theorems and then apply those. And the first theorem we're going to look at is Theorem 510, and it simply says this. If you have two sides of a triangle, so if two sides of a triangle are not congruent, then, notice theorems are always in the if-then statements, in if-then form. So if two sides of a triangle are not congruent, then the larger angle is opposite the longer side. And let's just look at a quick example of that. Let's say we have a triangle here, ABC, and we knew that AC, the length of AC was greater than the length of BC. So if this is true, then that would imply that the angle opposite AC, in this case B, angle B, would have to be greater than the angle opposite BC. If this is BC here, the angle opposite here is angle A. It simply says this: if one side's larger than another, then the angle opposite is going to be larger as well. Theorem 511 is exactly this. It is a very similar idea. It's just the converse of that theorem. It says that if two angles of a triangle are not congruent, so if two angles of a triangle are not congruent, then, again, the if-then statement, the longer side is opposite the larger angle. And again, let's do a quick example. Let's look at R, S, and T. It's obvious here that angle S, or let's just say it's given that angle S is larger than angle T. I'm going to be precise. The measure of angle S is greater than the measure of angle T. That implies that the side opposite angle S, in this case RT, the length of side RT has to be greater than the length of the side opposite of T, in this case RS. So then again, if-then statements. If two angles of a triangle are not congruent, then the longer side is opposite the largest angle. That's the converse of 510, which is if two sides of a triangle are not congruent, then the larger angle is opposite the longer side. In plain English, it simply says this: the longer side will always be opposite the larger angle. Right? Longer side always opposite larger angle, larger angle opposite longer side, and that works both ways. Smaller side will always be opposite the smaller angle. So instead of smaller side, let's say shortest side. Shortest side, smaller angle. Longer side, larger angle. Let's do some sample problems. Let's name the largest and smallest angles here. Let's say you have a triangle WED, and let's say this was 11, and this was 7, and this was 5. So let's think about that. Of the sides, WB is the largest side, so that means E is the largest angle. So the largest angle angle E. You could also call it angle WEB. What's the smallest side, or smallest angle? Well, if you want to find the smallest angle, then you want to look for the smallest side. The smallest side here is EB. If this is the smallest side, then the smallest angle is opposite that. What angle is opposite EB? It's going to be angle W. Or if you want to, EBW. Now let's look at a problem where we're naming the largest and smallest sides. Let's say this was 109 degrees, and this is 53 degrees. Now, and let's call this A, R, Z. Well, if you know two angles, you always know a third angle. So if this is 109 and this is 53, then let's add those. 109 and 53, 12, carry 1, 162. So the third angle, all three angles have to add up to 180. So you go 180 minus 162. That's going to be 7, 10. 10 minus 2 is going to be 8, 18 degrees. So what's the longest side? The longest side is always opposite the largest angle. The largest angle is Z, so the longest side is going to be AR. What's the smallest side? The smallest side will be opposite the smallest angle. We have three angles here. The smallest angle is here, 18 degrees, so that's angle A. The side opposite A is going to be this side, which is going to be ZR. So the smallest side will be ZR. Notice that that's not clear from the drawing, but we have to remember that when we have a given drawing, that's not necessarily drawn to scale. In this case, it's probably not. So that's how you identify smallest sides and smallest angles, largest sides and largest angles. Now, watch the same video series, but part 2.